My name's Jeremy O'Brien. I'm Director of the Centre for Quantum Photonics here at the University of Bristol. Our centre is all about delivering new technologies in the information and communication domain that harness quantum physics for their operation. These technologies include secure communication systems, sensors which might have applications in environmental monitoring, in healthcare, in security. We are working towards quantum simulators which promise to deliver new molecules for new pharmaceuticals, new materials, new clean energy devices, and ultimately we're working towards quantum computers, so computers that harness quantum physics in their operation to deliver exponentially greater computational power for important tasks that include pattern recognition, face recognition, machine learning in big data and so forth. I've been very fortunate that EPSRC through the RISE Fellowship has paired me with Daniel as an editor of a newspaper and a member of the House of Lords. He's obviously a influential, important person, and it's fantastic to have him in our research laboratories and show him the technologies that we're developing and to talk about the impact that they might have.
I don't imagine for a second that I can learn all there is to know, or even a small portion of what there is to know, perhaps just a tiny portion, but the increased understanding and the ability to bring those worlds together and to take what I learn here, the discussions I have, the friends I make, and bring those back into the newspaper as we cover events daily, into the House of Lords as we discuss legislation. That's got to be helpful. And I hope in the other way, the things that I'm able to say about how the public policy world works will help people involved in science who often don't actually have much of an appreciation of that world and are quite sceptical of it, will help them understand what we do and how we think.
The science of quantum photonics is about taking tiny particles of light, the smallest possible chunk of light, taking its associated weird quantum behavior, putting all of that onto a chip, and using that chip to perform a useful task.
So my rising star is Pete Shadbolt. Pete was a PhD student of mine here in the Centre for Quantum Photonics at the University of Bristol, and he's now a postdoctoral research fellow at Imperial College. He is an extraordinary scientist and engineer, building the electronics that allow single photon detection to happen at the nanosecond timescale, right through to foundational aspects of quantum physics, so exploring wave-particle duality, arguably the quintessential conundrum, if you like, of quantum physics.
We are not trying to make everything smaller and everything faster. There are problems which we care about. For example, machine learning, big data, simulation, looking for new chemicals, etc. And our classical computers, we can build one the size of the moon and it won't be good enough. If we can build a quantum computer in the style of the things which we are building on chip in this lab, then we should be able to tackle those kind of problems.
The question has moved from if to when, and that's a very exciting development from my perspective. Instead of being some esoteric, crazy quantum physicist's idea, it's now expected to happen, and it will happen, and I'm absolutely convinced of that. And by connecting up the research with the real world, I think the UK is very much ahead of the game through schemes like this RISE program.